G'day guys and welcome back to my channel. I don't know what to say, the plot thickens, quite literally. Probably shouldn't leave something in front of the soldering iron, it's an aerosol can. So the 500 ohm pots that I pulled out that were starting to get buggered, I put two 5k pots in. Channel 1, yeah, the current turns up too high with the 5k pot and I was going to trim it down. But the voltage still only went up to where I wanted it. And incidentally, that little trimmer pot that I put there on the back of the constant voltage pot for channel 1, I set the max at 30.25. The reason I put the 0.25 there is because under the full 1 amp load it might drop 250 millivolts. I don't know how accurate this thing is. I haven't tested it yet. You know, if it's accurate to like a millivolt, I'll set the max voltage at 30 volts, you know, or 30.001. You know what I'm trying to say. Anyway, that's not what this video is about. So this is bewildering me. And now I'm starting to wonder if someone has possibly, the person who's carried out all the repairs in this thing over the years that weren't done right, if they've done something else wrong. Because when I changed the 5k constant current pot for the master channel, and this is with in independent mode, so it's two separate supplies, they're not linked together when it's in independent mode. When I put the 5k constant current pot on the master, the voltage still goes up to 30, but the current goes too high, which was expected. The slave, when I put the 5k pot in there, well, the current's acting all weird, like you can't set it, it's got offsets and all sorts of weird stuff, and the voltage goes up to 54 volts again. Anyways, I got my cleaning solvent and I cleaned out the 500k pots. I actually managed to get it down in there, fill the whole pot up to the point I could shake it and hear the liquid in there and just work it and work it and work it and shake it out, and I did that about 3 times. These pots are both working now. Now here's the interesting thing. As you can see, I've just tacked in the 500 ohm pot on the slave channel. This makes no sense. With that in there, perfect 30.1 volts. You know? Now that's what I meant to set the other side to, 30.1, not 30.25. One sec, sorry, I'm a perfectionist. Everything I do has got to be... I just want everything to be like bang on so I can just leave it there and be happy with it, you know? For years to come. Oops. Alright, so they both turn up to, oops. $30.1. 30.2. It's close enough. They're basically the same. Alright, I've trimmed the voltage pots. But the point I'm getting at is, why is it when there is a 500 ohm pot on the constant current for the slave channel, the voltage goes up to double, but on the master, it has no effect on the voltage, just the current as you'd expect it to? Does that mean someone's done something wrong? Like, I don't know, maybe over the years of all the problems it's had, one of the reference voltages went missing or something, and someone's moved a wire so that this is getting its reference voltage from the voltage reference, not the current reference, and it's tied in with, I don't know, I'm just trying to imagine how this can be doing this. I just don't get it. Although You know what? I know how to work this out. If it's wired wrong or not. Because the only other thing I can think of is the auto tracking setup. One board does have one extra pin on one side. There's a couple of traces that are mounted different. In between the constant current set pot on the master side, there's a resistor that goes to the auto tracking switch. And on the slave side, there isn't. So it could just be, if this has got 1.125-ish volts across it, then it is wired up correct. Oh. Well, okay. Well, I think I know what I'm going to do. I'm just going to put the two 500 ohm pots back in. I've got them working. It was just dirty. That's why it was intermittent, not because it's loose. Just had dirt in it. So that's good news because when I saw the plastic welded back, I was like, oh, great, I can't get into them. But I started trying to spray into like little cracks and stuff, and I was already getting in there, and then I found this gap in here, and I was able to fill up the whole thing and shake it around and work it. And I mean, just so you guys can see how they're acting now. The worst one was the bottom. It was all jumping all over the place. I need to clean my pogo connectors. They're dirty. That's not the pot. That's just my connectors. Oh, get on there. Wait, don't tell me that is the pot. Oh, it is. When I push down on that last tab, it is intermittent. Ah, bummer. Oh, that is so annoying. I wonder if I can sort this out. It's literally my last option. Because otherwise I have to wait and get two 500 ohm multi-turn pots. Like I have to order them and wait for them to turn up. Goodness. This is so close. I can't believe this is happening now. I think I have an idea what's wrong with this too. Yeah. You know how I was saying if you get solder to flow inside it, flux will go inside it and it'll screw it up? Whoever's owned this before me has done that. I'm going to see if I can pop this back off. Clean that last ring. Work out why it's in a minute. And just like super glue it back together or whatever. That's actually one of the ends that the wiper connects, not the wiper, the element itself connects to. So what I'm wondering is if the elements come desoldered from it because there was heat on it. The elements just soldered to the tab inside. I've pulled these apart before and had to fix them. Just not sealed ones like this. Yeah. That's not it. That wasn't even soldered down. You see that? It's just a press fit. I can fix this. So that's the wiper. I wonder why it isn't soldered down. You'd think it should be, hey? All the ones I've pulled apart it was. Hey, get out of here. Get out. I'm just trying to see what's supposed to, if it's supposed to be like a press fit, and there's something that's supposed to push it. Yeah, I'm not seeing it, eh? That's definitely what's happened, but a little bit of flux has gotten in between that little piece of metal there, and because it was press fit to that ring. It's come disconnected. Well, it's not come disconnected, it's only press fit. It just wasn't making contact anymore. Well, I can do that, I guess. Getting this back together is going to be interesting. I'm going to have to go in a minute. One of my mates is going to be here. But I am determined to get this finished today. Because I've soldered it, that little bit of solder's just in the way of that plastic there. That's alright, I know what to do. Just made it a very, very small amount more clearance. Ah, fuck, I knew that was going to happen. Can't get super glue everywhere in this. I'm just going to clamp this together in my vise for a couple of minutes. Now obviously I'm going to still order new pots. Okay, I'm going to order 2 new 500 ohm multi-turn, more than 2. But I'm definitely going to order new pots. This is just so I can get the supply up and running for now, you know, like, yeah. This is obviously not a temporary solution. I'll just stop this video and join it to the next one. When I come back, I'll take that pot out when it's dry. I'll install these 2 pots back in it, and then we'll come back and calibrate it like what we were about to do yesterday. And I guess, what did I choose here? The values. 10K. Yeah, that's to trim, I'm pretty sure, the 500 ohm pots. Yeah. Or was I going to use? I'll go 500K. Just makes more sense. 500K. So these are, yeah. Oh shit, these are 1K. Oh, that's because I was going to use these to compensate the, what do you call it, the 5K multi-turn pots that I put in there. So that makes a little bit more sense. Alright, so I want 500K. There we go. If you're trying to knock off just a really small offset to trim something, you're going to want the trimmer pot to be basically 100 times the value of like the original pot. Any lower, it's just going to basically be trimming it before you even start adjusting it. I hope I said that so that makes sense. These actually do get trimmed in the same way, seeing as we're going back with the 500 ohm pots, so I will be just cutting 1 pin off and sticking it across end to end of the, not from the wiper to one end, but end to end on the pot. So cool. So that basically I can just trim that 1 point whatever volt that's on that pot, so that I can set the current to exactly 1 amp when the pot's turned up at full. Because even with the 500 ohm pots in there, the current wasn't perfect. One went up to, I don't know, a little bit more. I can't remember, 2 amps or something. The other one went up to like 1 point something. Yeah. And the current control works great. So I'm not going to change the resistor values and the dividers that go back to the op-amp and stuff like that, and the current shunts. Like, it's because I put new op-amps in there with more gain, I'd say. They need different set resistors, and that's why it's throwing the current limit out a bit. Or maybe the shunt resistors are more off spec than the original ones. I don't know, but like I said, it doesn't affect the performance of it, so it's perfectly viable to just trim it across here. Alright, well, I'm going to go put these 2 pots in. Incidentally, I still got to clean that one, and I might do the same thing to it, I don't know. But that's the thing, the top wiper would only be press fit too. Doesn't inspire faith. I think I'll just leave it as it is. Like I said, I'm ordering 2 new pots anyway, so why put effort into it? Alright, well, I'll go install these pots and then we'll come back and calibrate this thing. Alright, my apologies for holding the phone. I put the 2 500 ohm pots back in there. This one, I didn't end up opening it. What I did is I put the meter on it and I really gave the pins a wiggle and it seems tight. There's no play in it. So I don't know, maybe that was just buggered from factory. Maybe they're supposed to be soldered. Maybe there's supposed to be more pressure on there and just, I don't know if it is like a press fit. But anyways, this one's still, you gotta like hold the current down to get it to go all the way down. But it does work. And if I put the multimeter on it, you can turn it down to 0 amps anyway. And I'm sure when we trim it, it will go down to 0. And this one is working too. And as you can see, my voltages are calibrated too. You guys know that it's just those 2 pots to set the high volt limit. So what I'm going to do now is I'm going to tack these 2 pots across end to end across that reference voltage on the constant current pot so that we can turn them both down to where they need to be to limit the current at exactly 1 amp. And then I'll come back when they're installed and we'll set it, and then we'll set the panel meters. Shit. Got a bad habit of not screwing the boards in and yeah, anyways, yeah, so then we'll come back, we'll adjust the panel meters. Yeah, that's it. I already set the voltage on them, but we'll do the current because that's off. I made the mistake of twiddling the current pot, forgetting it was for that, and then realizing what it was for. Wondering if it had an effect on some other part of the circuitry whilst looking at the outputs the other day, and then I remembered, I was like, bugger, that was for the calibration of the meters, so we'll redo them. I'll be back in a moment. Alright, so I still haven't put these 2 pots on to trim the constant current. I'll get to that in a minute. I just wanted to check out the voltage, because I put a trimmer pot, as you know, on the back of each constant voltage pot, and I set it so like the master 30.01. Anyway, the slave, right, originally when I put the trimmer pot on there, it was already too low. After the supply warmed up, it was like just about on 30 or on 30. So I pulled the boards out, checked my references. Sure enough, I bumped the pot on one of the references. It wasn't at 5.1 volts, it was at 4.89 something. I've reset that to 5.1 volts, checked both the references are bang on, put the board back in, and now sure enough, I need the trim pot to trim it down to 30 volts. So that's all well and good. So as you can see, both sides, that's voltage up all the way. Both sides are, get in there, trimmed, and both the panel meters are bang on accurate, right? Here's where something's up. Something's up. No, you know what I'm trying to say. When I put it into auto tracking, you see the one on the right, it goes up. Don't worry, it's not going up to 54 volts or something stupid like that. But look. $31.64. If I wind it down, the ratio adjust to what the other one's on, and then adjust the other one, it tracks. 24.76 should be like 24.75, I think, because it was a millivolt off. See? Tracks perfectly. But the thing is, and I know I'm 100% certain of this, 100% certain, the way I had this, it only went up, sorry. Hey, that's over 30 volts now in independent mode. Hey? You know what? You know when I took the constant current pot out this side and I changed it and it behaved differently? 30.07. It is just slowly coming down. That was just a capacitor charged up. Okay, fair enough. That worried me for a sec. I thought there was another problem I was going to say. Don't tell me my voltage is going off. So I don't understand why when I turn this up to full, the, what do you call it? The voltage goes from 30 to 31.65 in auto tracking mode. I don't get that. And I don't know if that's right, how it holds it there for a minute either. It's a little bit odd. I swear that is going higher than what I set it. Sorry. It's a bit awkward to, I only have two hands. Okay, no, it is returning to where it was. That panel meter is just a little bit off. I guess I was just looking a little bit to the right when I tweaked it. I'll just retweak the panel meter just to make sure that. Fuck's sake. That's better. Alright, I got that back how I want it. Let me just play around with it and see. Yeah, okay, so that was just a panel meter, that's fine. Alright, so I'm really curious. Yeah, it's all well and good. I can put these pots in and calibrate the current limit like I have with the voltage limits, but you guys are probably starting to get to know me. I'm a perfectionist. I don't understand why the auto tracking's thrown off. The only thing I can think of, I'm going to take the boards out and just trace it out with my multimeter, the auto tracking and independent switch. I'm going to trace out where those wires go back to on the board and see how, reverse engineer that part of the circuit in my head too and see how it works. Because there's a chance that, like, you know how I replaced some resistors in here, and I'm talking about on the lower board, I didn't point this out in the video, but they were 1% resistors, and some of the 1% resistors I actually replaced with 5% resistors. Well, it could just be that. It could just be a tolerance of a resistor being off, and then that's mucking up the ratio. I'm pretty sure it is just that. And if it is just that, I'm just going to leave it. I'm really not worried about that. You know what I mean? That's perfectly fine. When you go and put it into auto tracking, you're going to set your ratio every time anyway, because the other side could be on, well, any set voltage, so the ratio could be any spot. So it's not like it's going to bother me or be a problem. So if it's just because one of my resistors is out of tolerance to what it should be, then it's not a problem. The supply's fixed. And I think it is fixed. But I just want to be 100% certain that there's not some little quirk going on, because I still don't understand why when I took the constant current pot and changed it for a 5K in this side, it mucked up the voltage, but on the other side it didn't. That's a bit hard for me to wrap my head around. But in saying that, it kind of makes a little bit of sense, because these two references on the top, they're actually only for these two op amps that do the panel meters. So, my cats are going nuts. So because those two references are for the panel meters, that means the other two references are what's being used to compare everything. So what I'm saying is there isn't a separate reference for voltage and a separate reference for current. Or there might just be a reference for one and not the other. Just depends like how it's built. I haven't traced it out that much. So I forgot what I was saying. The auto tracking problem. Yeah, I've completely forgotten what I was saying. Man, I got too much going through my mind right now. God, I feel like a dumbass. Sorry. If it comes back to me, I'll mention it. But yeah. Anyway, I'm pretty sure it's just down to resistors. I'm gonna trace it out. But I think I remember what I was getting at. I think what's going on is this: two op amps. One monitors a divided down voltage of the voltage, and the other one monitors a divided down voltage that's divided down off of the current sense resistor. Those two op amps, I think then it's using another op amp to compare it against a reference. Actually, that doesn't make sense, because yeah, maybe only the constant current has a reference. I don't know. There again, maybe they are using the top two references for dual purposes. Actually, that's quite possible, because yeah, that makes more sense. Maybe they're using the two 3.6 volt references for the panel meters and the constant current. Yeah, and the 5.1 volt references for the constant voltage. That actually makes a lot more sense. I think that's what's going on. Anyway, that doesn't really help me with trying to work out what's going on with the auto tracking mode going up. But the thing is, I know 100% before, when I turned them both up to full voltage, when I flipped it to auto tracking, the second one stayed exactly where the first one was. There was no difference. Yeah. Been interesting. So that's all right. I'll go trace out where the auto tracking switch goes to. Check the resistances on the pots I put in to make sure that there's not like some slightly different values of resistance between the not the wiper and the track, but the tracks themselves. Because one thing I have noticed is the constant current pots, if you try and trim them down by putting a pot or resistance across end to end, like not the wiper, it actually drops the voltage a little bit. So yeah, I don't know. That's what I mean. It's weird. It kind of seems like they are using one reference for constant current and constant voltage, and then the other reference for the panel meters. But I don't know. I'll go trace this out. I'll work out what's going on, and I'll come back and report to you guys and let you know whether it's just a resistance tolerance problem, or no, there is actually something else wrong. I can tell you now, if there is something else wrong, it means that whoever worked on this before did actually like move a wire around somewhere, which wouldn't surprise me with all the problems it had. It seems like the person sort of just threw stuff in there and moved stuff around to make it work. Sort of work. So yeah, I'll be back soon. Alright, things were getting strange, so this this is just so everyone knows, this isn't even the same day, it's the next day. But things were getting so strange. I had to just sit down, take a moment, trace everything out, and just make sure that there was no funny business going on. Alright, so I'll just show everyone quickly what I have done. Because it would have taken so much video time going over it all. Excuse me. So I just sorted everything out, and I thought I'd come on and make an update and then upload this video basically. So I found caps that were leaking. When I say leaking, the spark caps that tested good before somehow have leakage now. At 30 volts, they're already passing 1 milliamp continuously. And no, that doesn't go away after time. It's just continuous. What else? Okay, the other thing I tried doing was the resistor divider that was on here. I don't know if anyone remembers, originally this side had a slightly different value resistor here and here. I can show you guys because I've still got the parts right here. Sorry, one resistor's trying to hide. I got it. Alright, that was a 10k that was there. Instead of a 10k, there was a 12k here. Right, there's a 2.2k there and a 1.4k there. And this is the master channel. So I thought maybe that had something to do with it. I put the original resistors back in. Lo and behold, still when I put it in auto tracking, the voltage goes up an extra 1.5 volts on the slave side. Anyway, I worked out what that is now. It's just oscillation. We just got to, what do you call it? Compensate all the opamps now. So the other thing I did was I'd installed a couple of MKT capacitors across the back of a couple of electrolytics I put in here. When I had re-gone over the circuit, I realised that the electrolytics weren't actually doing what I thought they were doing. So I took the MKTs off. I thought they were basically in part of a feedback loop, and I was trying to improve the AC frequency response, feedback response of that loop. But it turns out it was actually just for sort of keeping the voltage constant across a resistor. So it's, yeah, electrolytic will do fine there. What else? I had to make notes. I came across that much stuff. Oh, the 500 ohm constant current pots. That's still in there. I had to fix them. That's all good. We'll fix one of them. It's still in there. That's as is. I've put all the calibration pots in there now, and I've calibrated it, and that all worked out. So I've got the voltage limit and the current limit, 30 volts, 1 amp on each side. That's great. Anyhow, it's still doing weird things. So when you try and measure current, when I went to compensate the panel meters, adjust the panel meters for the current measurement, it would come up to 0.8 of an amp, almost go up to an amp, and then kick back when the supply was outputting more and more current going up to an amp without doing any weird business. The voltage on the right channel keeps ending up in a slightly different spot, just arbitrarily. There's a few little symptoms. So it's pretty obvious to me that all the opamps are actually oscillating. So we're going to have to sort that out. I went over everything with a fine tooth comb, checked every single component again just to make sure that everything was good, and everything is good on here. I changed these two caps and these two caps because they were leaky. Other than that, yeah, everything is good. So I'm going to upload this video here because all that's left to do now, I might as well show everyone quickly before I do that because that would kind of be a bit pointless. I don't know if I'm gonna do any more videos, so I can barely talk. If I sound like I'm talking funny, it's because I'm in a lot of pain. I have a toothache. It is killing me, and just talking is killing me. Yeah, there was still a resistor there. Right, put this in quickly. Oops, that wasn't good, but it will move. All right. Voltage on the right hand side. It still does this thing where it's off about 0.5 volt and it comes up slowly. It's actually an oscillation. It always comes up to a different figure, no matter where you set it. That was one of the things that gave that away to me. And yeah, in my time yesterday, I changed more op amps, and no, that didn't solve it. So I know it's oscillating. Anyway, that does come up to 30.01. The first side just, the first side just comes straight up to 30.01. No problems at all. Oh, apparently the first side does the same thing, just not as much. Alright, let's put the voltage down. Current. Alright, all the way down. One amp. Oops. One amp. Meant to turn that down. Oh well. So yeah. Also, I'll just show you. Give a bit more current. If I turn the voltage up to full, and then turn the voltage up to 4 on the first channel, and put auto tracking on, sorry, I didn't have the current turned up on the first channel, the voltage still goes up too high. And yes, I saw that voltage shoot up when I flicked the switch. Yeah. Like I said, everything's oscillating in here. That's all we've got to do is compensate everything. But the good news is, if I turn it back down to where the other side is. Good enough. And then turn the other side down, and then measure the other side. It's tracking perfect. So all I got left to do is compensate the opamps. So I'll upload this video because I am 100% certain now that everything in this supply is good. There's no more need to change parts. I'm happy with everything that's in there for what it is. So yeah, all we've got left to do is bust out the scope, see what's oscillating, solve those problems, and Bob's your uncle, as they say. So, see, that's the other thing. We'll put into auto tracking and take it out. So, see, it's oscillating. Voltage ends up, just going everywhere. Anyway, there's a few things that hint at the fact it's in oscillation. Oh, the panel meters too. I'll just show you that in the next video. Literally just, they measure voltage fine, but when you put in amps mode, the needle goes up and then it kicks back at a certain point. So I'd say those op amps are oscillating, or where they're getting their signal from, it's got so much oscillation on it, it's screwing them up. Oh, my mouth is killing me. Sorry, guys. Alright, I'll see you guys in the next one. Thanks for watching. Take care.